Okay, so the first questions is what we discussed today about the numerical expression that has a very well-defined order to read and to evaluate. So we use the order of operation that we have been applying. Is the GEM does, right? So this grouping, you can see parentheses, you can see brackets, you can see braces, you can see absolute value, or you can see a fraction where you have to solve the numerator and then the denominator, okay? And if you have multiplication and division, it happens from left to right. And if you have addition, subtraction, also happens from left to right. And the order is absolutely like that. It's not an option. You have to look for groupings. So here on this numerical expression, I have two groupings. I have one that's marked by the brackets and another one that's marked by the parentheses. And the parenthesis is the inner one. So I start with the inner grouping and expand out. So we're going to work with this parenthesis here first. Okay? So when I work with the parentheses, I will repeat, copy down anything that I'm not touching yet. So I'm not touching the 3. I'm going to put it down. And until I find my parentheses. Now I look inside the parentheses and I see a multiplication here and I see a subtraction. Multiplication has priority, so then I'm going to multiply this. Keep the parentheses and do this multiplication. Everything else come down. So I want you guys to learn to be very neat and organized, because the things that I see mistakes that you guys made is being very messy, putting multiplication here, the subtraction there, and then when you put all this together, the thing becomes unorganized. Now I'm still solving this. I didn't finish. If I come back here, I still have this grouping to solve. Then I'm gonna put it down anything that I'm not working with. So I put down the 3, 2 plus the 3. Now I'm solving this parenthesis. When I subtract this, I get number 7. My parenthesis is not necessary for grouping. However, what is 3 doing with this here? Multiplying. Multiplication we indicate with parentheses. Now I'm going to use the 7 between parentheses, not anymore because I'm grouping, but because I'm indicating a multiplication here. So then I close the bracket. Okay, so when I look to this, I see that there is addition here and a multiplication inside this grouping. Which one I'm going to do first? The multiplication. I look my GEM does. Multiplication has priority over addition. So what I see today in class, you guys would look to the addition and start adding. So you don't add this at all because multiplication is priority over the addition. So I'm not dealing with the 3. I'm solving just this multiplication. 2 plus 21. Now I have only one operation. What is 2 plus 21? 23. I will not use brackets anymore because I'm done with this grouping. But I will put my 23 between parentheses. Why? Because the 3 is multiplying this 23. And then I keep a parenthesis. Then I multiply 3 times 23, 69. So when I see you guys doing work, it's this that I am looking for. I want to see the sequence. Okay? Put down what you don't use and carry over what you and solve what you are trying to deal with. Okay, let's go to the next one. The next one is a multiplication. So those are whole numbers. I just put my multiplication at work, how I so I'm going to put here my 868 times 629. Okay, so here I have 8 times 9, 72. Carry 7. 6 times 9, 54. Plus 7, 61. Goes 6. 8 times 9, 72. Plus 6, 78. So I multiply the 1. That is the 9. Now I'm going to multiply the 2 that's on the 10th position. So I must fill this with a 0 and start the multiplication of the 2. 2 times 8, 16, goes 1. 2 times 6, 12, plus 1, 13, goes 1. 2 times 8, 16, and 1, 17. Now I have to do the hundreds position. So I'm going to add 2 zeros and start the hundreds position. 6 times 8, 48. 4. 6 times 6, 36, plus 4, 40. Goes 4 again. 6 times 8, 48, plus 4, 52. Now I'm going to add everything. So the multiplication by the ones, by the tens, and by the hundreds. Now I do 2, 7, 19, 15, 4, and 5. Right? So remember to shift with the zeros the position that you are working on. Okay. So let's go to the next one. Alright, so here they say also to use order of operation, the same thing. GEMDAS that I wrote on the first problem, right? So let's see, but then they let very clear. It's okay, this is addition. You step out and you see there is a, let me mark with the green. There is a grouping here happening, here to here. There is another grouping happen here to here. Is this parenthesis here a grouping? Yes or no? Now, why this parenthesis is there? Because of the negative sign to the 9. Just to indicate that I'm adding a negative 9. So there is really only 2 groupings. So I'm going to solve the 2 groupings. Because they are separate, I can solve them together. They are not one inside the other. On that other work, I had one grouping inside another grouping. So what is this? This come up to 10. So the 10, you guys have to be able to be very good solving addition with different signs. So those 2 are adding together. Different signs, I subtract the number and keep the sign of the bigger number. So then it's a 10 positive. Here, this will be a negative 6. Different signs, I subtract the 2 numbers. 9 minus 3 is 6, but the sign of the bigger number is negative. So then 10 plus negative 6. And I solved this grouping, but I kept this parenthesis to indicate the negative, to not mix this with that. Then I do plus negative 12. Now it's just addition. Then I do from left to right. 10 plus negative 6 is a 4. I subtract, they have different signs, I subtract, keep the sign of the bigger number. Plus negative 12. Here also I'm adding different signs. Then I subtract the 2 numbers. I get 8, but I keep the sign of the bigger one. So then my answer is negative 8. Yes. Yeah, because, so pay attention. When I have a number next to the parentheses with no operator here, this indicates multiplication. But if I have this 3 plus a negative 5, this is only to indicate that your number is a negative and is being added to 3. Okay? So you have to look for the operators. If you don't find an operator in between and they are connected to each other, is a multiplication. Okay? So this is how you distinguish.
There's no number on.
Yeah, there is a 3 here outside. There is a parenthesis and no operator here, none.
Okay.
So it means multiplication.
Okay.
Yes. On the question 1? Yes. 3 times 7, yes. Okay, so when you're doing numerical expression, if you want to distribute the 3, but it's not the efficient way to do. The efficient way to do is to solve the grouping first, find one number, and then multiply the result by 3. If you distribute, you have more work to do. So it's for an efficient manner. When you have a numerical expression that only has numbers, you never do the distributive property. You try to solve the grouping and then multiply. But if you do and you're careful, you must find the same answer. It's just not the most efficient way. Okay? But it's a good question, definitely. Okay, here became clear that, so remember that I told you that the parenthesis has different purpose. The parenthesis, it's like you find a word, I was illustrating the word bear. The bear can be an animal, can be a verb, can be something else. So the parenthesis here, depend where the parenthesis is on the expression, has a different purpose. The purpose of this parenthesis here is only to delineate the negative 6. Here, the purpose of this parenthesis is for grouping. On the previous problem, the purpose of this parenthesis here was to multiply. Okay, to indicate, here is to indicate multiplication. Okay, so now is the question number 4. Again, another numerical expression. And I have to remember gendas. Gendas says for me to look for grouping. How many groupings do you see here? You see 2 groupings. You see an outside grouping that is here. And you see an inside grouping that is here. So when one is inside, nest inside the other, I have to do the inner one first. So then I repeat anything that I don't use. Then I solve this. What is negative 5 plus 1? Negative 4. Different signs, I subtract and keep the sign of the bigger number. So it's negative 4. And you see that exponent is for the grouping. Now I put the exponent there. Now I still on the inside. Now I have another grouping. This has subtraction, a multiplication here, and an exponent here. Which one I'm going to do first? The exponent, because gem does. So the exponent. I'm going to solve this. What is negative 4 times negative 4? A number, so exponent means multiply the base by itself twice. This is the number 16 positive, right? And then I replace. I didn't touch this, I repeat. Do I keep the 16 between parentheses? Yes, because the 3 is multiplying this result. So I put here the number 16, nor more, not because of grouping, but because of multiplication. Now look inside here. I have a subtraction and a multiplication. According to the order of operation, what should I solve first? The multiplication. So then I repeat things that I don't use. This is a negative 3 multiplied by 16. Negative 48. It's negative, right? Yeah, you have a negative for the 3, and you have a positive for the 16. When you multiply, you have a 48 negative. Now, this. Yeah, because how happens with multiplication? Multiplication, if we have same signs, the result is positive. If I have different signs, the result is negative. Right? Now, what is the result of this? I have a 3 positive and a 48 negative. I subtract the number and keep the sign of the bigger number, negative 45. But what happened? There is a negative here that I carry over since the beginning. So then my final answer is the number 45. Positive. Yeah, because negative with a negative makes a positive. Okay? Okay, now we're going to go to number 5. Number 5, they tell me to subtract this. And how do I have to give the answer? As a reduced fraction. So this that I'm saying, you know what to do, and this is telling how they want the answer. If you do not reduce your fraction, your question is incorrect. Okay, so let's start. Fraction with different denominators. I have to reduce those fractions to the same denominator. So first step is find the LCD, the least common denominator between the number 12 and the number 28. Right? A common denominator. I will use there is 2 processes to use there. I'm going to use the prime factorization because it's more efficient instead to find multiples. So I'm going to get 12, the 28, make a line vertical. So this LCD is always bigger or at least equal of one of them. But it has to be bigger. You're not finding something to simplify. You are finding something to expand. And then so I do prime factorization because Go is more efficient. And you have to remember the sequence of the primes. What is the first prime? 2, right? 2 is the first prime. Can I divide by 2? Okay, so I'm going to use the 2 here. Then I have 6 and 14. Can I use the prime 2 again? Yes, then I use 2 again. Now I have 3 and 7. Can I use the 2? Not anymore. What is the next prime that I can use here? 3. Then I put 3 here. 3 divided by 3 is 1. This is done. But I cannot divide 7 by 3. So I repeat what I cannot divide. Now, what is the next prime that I can use? The 7. I cannot use 5, so it will be the 7. Now 1 and 1. Done. When both are 1, you're done to find all the possible primes for this combination. Then you multiply this. 7 times 3, 21. 21 times 2, 42. 42, 84. Times 2, 84. So this is your LCD. So the LCD is this number. Now, when you find the LCD, you need to find an equivalent fraction of each one of them with this new denominator. So I'm going to write here 84 for both fractions. And it's my goal to figure it out how 12 turning into 84. If you do not want to do any calculation, look here. How do you make 12 with those 4 numbers? 3 times 2 times 2, right? What is left? The 7. So it means that I have multiplied this by 7 to make the 84. Then I do the same with my numerator. Then my numerator must be multiplied by 7. Now I have 7 here. Now 28. How do you make 28 with those 4 numbers here? 7, 2, and 2. Then what is left? The 3. So it means that this number is multiplied by 3 to make 84. Now you do the same here. 13 times 3. 30. 39. Right? So now I have these two, same denominator, equivalent and same denominator. I will give my result. Okay, so when I subtract this, what do I get on the denominator? 32. Negative or positive? Negative, because the bigger number is the negative number. I subtract 39 from 7, and I get 32, but negative 32. Is this a reduced fraction? No. What is the common factor between 32 and 84? 2 would be 1, but is the biggest one? 4. So I'm gonna use the greatest factor. That is the 4. And then what do I get? Negative 8 divided by what? 21. So this is my answer. And if you put this answer here, is incorrect, because you know what to do, but did not pay attention how they want your answer. Okay? Question, yes. Now, there is not a double negative. So when you put this together, this will be 7 minus 39 divided by 84, right? Because you keep the denominator and do this operation on the numerator. Now your 7 is positive and your 39 is the negative. When I have addition of 2, you subtract the number. Got it? So you got it there? So you subtract the number and keep the sign of the bigger one. Subtraction. Yeah, because this is a very, very good question, because the point is, when we start dealing with integers, that's positive and negative numbers, the subtraction really does not exist. What exists, so there is an invisible plus here. So I'm adding 2 numbers, the number 7 and the number negative 39. And when I add numbers with different signs, what I really do is the subtract the numbers and keep the sign of the bigger number. Okay? Yes, it's how you have to look at. Because, yes, exactly. So, number 6. Okay. This one, they want in which form? How they want your answer? As a reduced fraction, right? So if I go to I'm gonna find different denominators. So I need to convert these to equivalent fractions where every fraction has same denominator. So then I have to find the LCD between 5 and 6. This you know that is 30, and you don't even need to do that prime factorization. Why? Because is 5 a prime? The number 5 is a prime. How do you make 6? 2 times 3. So the 6 is multiplication of 2 primes, and 5 is another prime. So you already have all that you need. Then you have the 2, the 3, and the 5. And then you multiply. 5 times 6, 30. So any time that you have numbers that are factored into prime and the primes don't match, you multiply the numbers. Then this will be your LCD. Okay? All right, so now I have 30 as my denominator. Then I'm going to write here. Here has a plus. But again, when I change the denominator, I must change the numerator. So how 5 turn into 6? How? Multiplying by 5 turns into 30 by multiplying by 6. And 6 turns into 30 by multiplying by 5. So you indicate this here. And now you work your numerator. My numerator be what? Here. 24, right? Because 6 times 4, 24. Now 5 times 5, 25. For my luck, the other fraction is exactly the same. So I am just, 4/5 correspond to 24 third. And 5/6 correspond to 25 third. So first part, see? Because this here and this are the same fraction, right? And then I repeat here and here. This one is the same fraction as that. Then I repeat here and here. But one has a plus, the other has a minus. Then what do I do? The first one, what is the fraction result with this addition? Okay. 49/30. Divide by what? -1/30. Now you must know division of fraction. You use what we call the keep, change, and flip, right? So the KCF. I keep the first. Okay, so I keep the first the way it is. I change to multiplication. And I flip. I get the reciprocal. The reciprocal is negative, but 30/1, right? I don't want to do this multiplication because it's a lot of work. But I see a 30 on the numerator and a 30 on the denominator, and they're multiplying. Then I can divide each other. Then I get 1 here and 1 here. Now my answer is what? -49/1, that is -49. So you don't put the 1 on the denominator because they want the reduced as possible, as a reduced fraction or as an integer. So this is an integer. Good? Okay, number 8. Multiplication. Now we are dealing with decimals. Okay. Multiplication of decimals, I don't align. There is no alignment. It's just the analysis at the end, right? So I'm going to put the one that has most digit first, and I'm going to multiply by 328. They want to know if it's okay. The result of this multiplication will be positive or negative. So I already put a negative here, just that I don't forget. And I'm going to do this multiplication. 32, 3. 72, 75. 7, and then 8. Now I'm going to go multiply the 2, that's my tenths. So I put a 0 on the ones, and start. 8, 18. 1 here, and 2 here. No? 2 times 4, 8. 2 times 9, 18. Goes 1. Oh, yeah, no, because, sorry, yeah, need that. Okay, so this has 1 here. And then I'm going to now multiply the hundreds. And then I put a 0 and 0. And I start. 3 times 4, 12. 1. 3 times 9, 27. And 1, 28. 2. Then I put a 2 here because 3 times 0 is 0, plus 2, 2. And then 3 times 1, 3. Now I add 2, 13, goes 1. 15, 16, 17, 18, goes 1. 10, 18, goes 1. 5, and 3. 3, so now start for me to look the decimals. The point was here. The other one, the point was here. I look how many decimal places my first number has. Has 2 decimal places. The second one also has 2. Now the product has to have 4. So I start from right to left and I count. 1, 2, 3, 4, right here. Now let's mark what the problem, how they want me to give this answer. Okay, write the answer as an integer or decimal number rounded to the nearest hundredths. What is the answer then? 35.88. I cut those 2. This is a number less than 5, so I don't add anything to the previous one. And this is out because I want to round to the nearest hundreds. So this is the 10th, this is the hundredths. So I don't want anything after that. Yes. Now, the decimal point, this is the 1, this is the 10th, this is the hundredths. When you walk to the right, this is the tenths. Remember tenths with TH. This is the hundredths with TH. And then this is the thousands. And the last one is 10,000s. So you have to look back that table on the chapter, the pre-chapter C. Because of the 3 after is smaller than 5. A 6, this would become a 9. Yes, got it? Good? Any more questions? Okay. Okay, so this is a numerical expression. It's a numerical expression. An equation has to have the equal, remember that? Yeah. No, but yeah, that's good. And so this just has number and operators. And then this is a numerical expression. So what do you solve here first? The parentheses, right? Because it's grouping. Okay, so I'm going to do 5.7, and I'm going to add 6.63. Remember, adding subtraction, then the decimals must align. It must. If you don't, so you're going to add 1s with 1s, 10s with 10s, and so forth. When I don't have a number on that position, what do? I fill with a 0. Now I do my addition, because this parenthesis tells me to add. So I have 3 here, 13 here. Now I have 12. This is 12.33. Now I'm going to do 6 minus 12.33. Now you have a addition where this is the negative number and here is the positive number. Different signs, what you must do? Subtract the number. You get the bigger one, subtract from the smaller. And you keep the sign of the bigger one. So what is the sign of your answer? It's a negative. So immediately, remember to do that. If you can know already, put the negative there. Just hold place. Now you're going to do, you subtract 6. 6 is ones. Then I have to put on top of the 2. The bottom of the 2. Now I fill everything with a 0, put a dot here, decimal point, and I work on the subtraction. 3 minus 0, 3 minus 0. Now 12 minus 6. So my answer is 6.33 hundredths negative. Good? So this is number 8, right? Okay. Now let's do number 9. Okay, number 9 tells me to simplify. This is no longer a numerical expression. This is an algebraic expression because it has the variable z. And it's an expression. It's still not an equation. I don't have any equal sign here. And they tell me to simplify. What are the two methods that I use to be able to simplify algebraic expression? The distributive property, combine like terms. Okay? All right, so do I see distributive property that should be used here? Yes, 2, right? On the first set and on the second one. I'm going to do that. So I'm going to mark here my distribution and then pay attention with the signs. 2 negatives multiplied makes a positive. Now I have 6 what? 6z. The second number is negative with a positive, makes a negative, and this is a 3. Now here again, 8 here and 8 there. Because you remember when you have a numerical expression, you solve the parents because you can. Here we cannot at all. This is the reason that I do distributive. What happened here? What is the number? Negative 56z. And here is plus 56. No more distribution. Now I'm going to use the combination of like terms. So I have a variable term with a z, another variable term with a z. I look to their coefficient and I add them. What is 6 plus negative 56? Negative 50z. And here is a constant, there is another constant. One is negative, the other is a positive. Then I have to subtract them and keep the sign of the bigger number. What is the bigger number? 56 and has a positive. So then this is a plus what? 53. Can I combine farther? No. So this is it. And you have to pay attention that I start with a mumbo jumbo of things, multiplying and doing a bunch of things, and reduce to a binomial, just 2 terms. Okay? Now we're going to do number 10. Another problem that is what? An algebraic expression. Now the variables is x. I have to try to use just those 2 methods, distributive and combine. I know that I can do distributive on both. So let's do 5 times x, 5x. 5 times negative 5, negative 25. What is half of 8? 4. So don't try to deal, when you see a half, you just cut in half. Don't try to make multiplication of fractions and take forever. You read, what is half of 8? It's 4. Negative or positive? Negative, because this is negative and this is positive, and I'm multiplying. Then it's negative 4x. Next one. What is half of 6? 3. Positive 3 or negative 3? Negative 3. Because multiplication of different signs give negative. Now, there is no more distribution. I'm going to try to combine like terms. I have two variable terms. 5x minus 4x. What is that? 1x. How do I write 1x? X. Negative 25, negative 3. Negative 28. Same sign. I add the numbers and keep that sign. Okay. Cannot go farther. I'm done. Okay, this one. Literal equation. I am not solving like for a number. I have how many variables on this equation? 3. What is this equation about? Formula for the perimeter, right? So, and I know that to find the perimeter, I have to do those two things here. I have to multiply the length and width by 2 and add together. But I want to solve this equation just for the length. So then I must what? Make the length, this variable by itself. Doing all this process of opposites and reciprocals. Okay, what is the first thing that I have to try to get rid of here? The 2w, this term here, this whole term. I want to get rid of it. Then I use the opposite. So let me put another color here to show that the action that I am taking. So I am taking the action to write the opposite on this side. And if I do on this side, I must do on the other side. When I say sides, an equation has the right side and the left side. And the equal has to be in the middle. So I am trying, my purpose is to get rid of this term. A number, a term, add to its opposite makes 0. Now my left side, I cannot combine those two because they are different variables. I write the p minus 2w, the left side. The right side, now I only have 2l's. Do I want 2l's or just 1l? 1l. So my coefficient cannot be 2, has to be 1. How do I make this into a 1? Divided by 2. Because a number divided by itself makes 1. And then I do the same thing here. Now I'm going to show different ways that you can represent this. So I can put a 2 all the way through like that. And then what is 2 divided by 2? 1. And then your answer can be, the length is the perimeter minus 2 width divided by 2. You can answer like that. When you type on the computer, for you to show that this whole thing is on the numerator, you must embrace this by parentheses. Otherwise, it will be wrong. Okay, so you can answer this like that. Or, let me show another way. So I am here, p minus 2w equals 2l's. I know that I have to divide by 2 here to make 1. Then I can separate, put 2 here and put 2 here. Separate. And then this becomes what? A p over 2. What this becomes then? Just w, negative w, and here is a l. You can answer like that too. So this is going to be correct in this as well. Is how you see the problem. Good? Any question here? All right. Both. Yeah. Both are correct answers. And you can preview them how you want. You have to get the habit to click the preview. And then if your preview doesn't look like your paper, you have to do something. But the something is, here you have a lot, more than one thing on your numerator. So it must have a parenthesis to put together. Then the whole thing is divided by 2. Okay? Okay, now we're going to go to the number 12. Now we finally got an equation. So we did the numerical, algebraic expression, now we have an equation. No, the previous one was equation, right? Okay, sorry. And they tell me to solve this equation and write as a reduced fraction or an integer. So what do you do here first? Get rid of parentheses, right? Yes. How? Distributive property, right? I'm going to apply the distributive property here. So 2 times 5 and 2 times 1. So this will be 10y minus 2 plus 18. 18 I just put down. Here, another need of a distributive property. Okay, so let's do the next side. Distributive property also necessary here. So here will be what? 18y minus what? 3 minus 15. Now what do I do? Combine like terms. On the left side, what can I combine? Negative 2 and 18, that gives me 16, right? It will be 10y plus 16. And what do I get on the right side? 18y and negative 18. Very good. So different, so same sign. I add the numbers and keep that sign. Think about that. I have $3 in debt, and then I incur another $15 in debt. Now my debt is 18. Yes. It's a real life story, right? Okay. Now I have variables on both sides. I have to bring variable to one side and take numbers to the other side. So what are we going to do here? What you guys want to do? This 16, get rid of the 16. Okay, so let me subtract 16. On both sides, I put under the constant. Doesn't matter. This is the reason that I let you guys, because it does not matter. At the end, everybody, if you did one thing first than the other, you must get the same answer. So a number plus its opposite, 0. Then the left side now only has 10y. And the right side now has 18y. Yeah, you're going to add those two numbers, both negatives. You add them and keep that negative sign. Now what you guys want to do? You can read both ways. This can be minus 34 or it can be plus negative 34. Always there is a invisible addition here. If you think as addition, this you are adding a negative 34. Because like I said, when I deal with positive and negative numbers, the subtraction does not exist anymore. Okay, now what do I do? What you guys want to do? Bring the 18 to the left side. Okay, so then I'm going to subtract the opposite here. And I do the same here. A term and its opposite, when I add together, becomes 0. Now, what is on the left side? What is the number here? Negative 8, right? Negative 8y. And what is on the right? Negative 34. Am I done? No. What do I need to do? Yeah, make 1 on the coefficient of the y. How do I make 1? Dividing by the number that is there, because a number divided by itself is the only way to make 1. And then here, negative 8. Then a number divided by itself makes 1. 1y is just y. Can I reduce this? How? Can I? Yes, no? And if yes, how? Divide by 2? And what else can I do? Can I, 34, 8 can be divided by 4, but the 34 cannot. So I'm going to try the 2. And what else can I do? Look the signs. Becomes a positive number, right? Because numerator and denominator are negatives. So what is 34 divided by 2? 17 and the 4 here, right? Positive number. Did you ask a question? What did you ask? Yes, yeah, because then it would become a positive. Yes, exactly. Yeah, good. Yeah, because dividing or multiplying same signs are always positive. What we are trying to be efficient is to bring variables to one side and numbers to the other. If we start moving the numbers this side, we're going to bring the variables to this side. But if you did the opposite, it would be right as well. If I brought the variable here or the variable there, I would have to bring the number here, right? That they will be in opposite direction. So this is the y that when I replace on the initial equation would make this left side equal the right side. Okay? Equation. What happened? I'm gonna do what here? I have already one variable on the left side, so I'm gonna move the number to the other side, doing the opposite, right? Opposite. Then this is 0. Now this is 3k. Now I will really subtract this. I cannot take away 8 from 2. I borrow this becomes 9, and this becomes 12. 12 minus 8 is 4. 9 minus 1, 8. Positive or negative? Positive, because the bigger number is positive. Now, what do I do with this 3 here? Divide by itself, this coefficient to make 1k. Now my k is 4 divided by 3. How do I make this division? 8.4. 3 goes into 8 how many times? 2. 2 times 3 is 6. When I subtract, I have 2 left over. There is a decimal point here. What do I do with this decimal point? Bring it up. Put right here. Then I put this down. 3 goes into 24 8 times. Then I have 24 left over 0. Then the answer is 2.8. If I multiply 2.8 by 3, I would get 8.4, right? 8.4 plus 1.8 is the 10.2. Then I'm good. I feel good that it is a good answer. This is the right answer. Solve the equation. I like this here because you see you have a bunch of fractions, and then you get in despair. Oh my God, different denominator. I have to find all that thing. No, I don't. There is a efficient way to do it. If you want to go to the hard way, knock yourself. And the answer must be the same. But if I find the LCD of all the numbers on my denominator is 3 and 5. What is the LCD for 3 and 5? It's 15. I know that I can multiply because this is a prime and this is another prime. And then I just multiply. And then I use this 15 and I multiply each term that exists on this equation. So I'm going to multiply 15 times 1/3 of y. I'm going to multiply, use 15 and multiply the second term that is 4. And I'm using 15 and multiply 1/5 of y. What is 15 times 1/3? It's 15 over 3, right? What is 15 divided by 3? 5. So then I have a 5y here. Everything with me. Yes? 15 times 4. 60. Because 15 times 2 is 30. Then times 2 again, another 30. Then I have 60. What is this number here? What is 15 times 1/5? Huh? 3y. This is the number 3 because this is 15 times 1 over 5. 15 divided by 5 is 3. Then this is 3y. So pay attention how much easier this is. Find the LCD of all your denominators, but the problem is you must use this 15 and multiply each term that you see on this equation, on both sides. You cannot miss one. People do this one and that one and forget the 4, and then does not multiply 15 by 4. Now what do you do here? Yeah, you can put the 60 there and bring the 3y here, right? So I'm going to bring the 3y first. Doesn't matter the order. 5y minus 3y, 2y. Here becomes a 0. 2y plus 60 equal 0. Now I'm going to take the 6 to the right side. This opposites a 0. Then I have 2y equal negative 60. What do I have to do here? Divide by 2 to make coefficient 1. 2 divided by 2, a number divided by itself is 1. And then I have the both sides, and then my y equal negative 30. Let's do now an inequality. Okay, inequality. Solve the inequality and give the answer. So solve inequality and equation, you solve the same way. You have to make the variable by itself. But you have an inequality instead of the equal sign. So I'm gonna, what can I do here? I can bring this here, and I can put the 9 here. But please do one at a time. Don't try to run out all at once because you guys messed up on signs. Okay, here is negative 12x. Then negative 12x. Here I have 8x plus 9 greater than negative 11. And this disappeared. Now I'm going to put the negative 9 on both sides. And this term disappeared. Now I have 8x greater than, what is this number? Negative 20, right? Two negatives adding together, I keep the sign and add the numbers. Agree? Now I divide by what? To make this 1, by 8 on both sides. Then my coefficient for x becomes 1. 1x is just x. Is this reduced? Now, what can I use here? What number to divide? 2 or 4? Can I use 4? Okay, I'm going to use the 4. So you have to find the greatest one. If you use the 2, you have to pay attention that you have to do the 2 again. Okay, greater than negative 5 over 2. Okay? So on this one, they just want the answer. And that's it. Say again? At this point here, there is no, if you had a less than here, it changes when you divide or multiply by a negative. For example, if I want to make this 1 and here was like negative 3x, you'd have to divide by negative. And then you'd multiply negative for both sides. You had to shift this. I think we have a problem here that is like that. I think it's this one. So let's try to solve this one. Here the x is already here, so then I have just to bring this 7 to the other side, right? So I'm going to get here negative 4x minus 7 greater or equal 1. I add 7 on both sides. This becomes 0. Now I have negative 4x greater or equal what? 8. Now is what you're asking. So what do I have to do to make this a 1? Divide by negative 4. So then I'm going to write negative 4 divide by negative 4x. And I have to do the same on the other side, negative 4. Then what happened here? It flips. So I go there and I'm going to put on green. Instead to be greater or equal, be less and equal. Because I use this negative on both sides. Okay? Yeah, see, it was greater and equal. Now it's less and equal because I use negative to multiply on both sides. It's just for the coefficient, not for the other term. It's just to change the coefficient. Now what is x then? X is negative 2 less equal, right? Which of your answer? This is the notation, the number line notation. A, B, C, or D? Pay attention. I want the numbers that are less or equal negative 2. Which one? And equal. A, B, C, or D? B, right? So the equal makes my negative 2 be a closed dot. And less than is to the left, right? And how can I test this? Suppose I choose this number here, 0. This should not make my inequality true. So if I put a 0 here, what do I get? Is negative 1 greater than equal 1? False, right? So, okay, this is out, like I saw. Let's get one that is inside my answer, negative 5. If you put a negative 5 here, you get what? The number 20, right? Positive. What is 20 minus 7? It's 13. Is 13 greater than 1? Yes. So I choose one outside my answer to see that it's false. And I choose one inside my answer to show to myself that I'm right. Got it? Okay. Oh, now we start with the word problems. Word problems. Okay, so I have a yard that has width and length. So I'm talking about then what type of yard? What shape is that? If it has length and width. Can be a square or can be a rectangle. So on my yard is 6 feet wide. So then this is 6, and here is also 6. It requires 72 pieces of sod that are cut 1 foot square. So I'm going to put grass here on my backyard. How many I'm going to use? The problem tells me how many. It requires 72. So I'm going to put 72 pieces inside of here. Each one is 1 square foot. So then I have 72 square foot. This is what? Area, perimeter. Area, perimeter. Area. Area is inside the thing. So if I rip this carpet and I need to know the area. And I'm putting sod on my yard. So I'm covering my yard with the grass. So this is area. So then your area is 72 foot squared. Because it says it used 72 pieces and each one is 1 foot square. So the total area of your thing is 72 foot square. How do you find the area of a rectangle? Area is length times width. Area is 72. The length is what I want. How long? I do not know. L. What is the W? 6. How do I solve for L? Divide by 6 on both sides. So this means that the length of my yard is 72 divided by 6. And this is 12. When I make this division, so let's see, 72 divided by 6. Go into 7 once. Subtract, go down the 2. I have 2 here, 12, and then 0. Okay, so 12 is the length. Got that? So you have to understand if they are giving you the area or the perimeter. It's very important because then you use a different formula. Done? Any question here? Another word problem. My room is a rectangular room. I always try to model. Like I model this. My first impulsion is to create my yard. Here is to create my rectangular room. A rectangular, But did you understand the area, the previous one? Okay, let's see this. Perimeter. They tell you the perimeter of my room around. How do you find perimeter? What is the formula for the perimeter? 2 times the width plus 2 times the length. Right? You know that. Your perimeter is given to you that is 42. Right? So your P is 42. What else do you know? This sentence here is the key of your problem. they're telling you that the room is twice as long as it is wide. For example, if I am twice her age, and she tells me that she's 20, how old am I? 40. Let's put that way. Let's leave that way. That's good. Okay. Understand, twice means that I multiply by 2. So I'm saying that the length of my room is 2 times the length of the size of the width. Do I know what is the width? No. Do I know the length? No. So give me a variable for me to use for the width. Just a variable, W for the word width. If this is W, what is this size here? If it is twice, it's 2 times W. Yes, very good. So here, this is 2W. Then I know that this is W and this is 2W. 4 times 4W. Or if it says to you that the length is 2 feet longer, you're going to add. For example, if I am 2 years older than her, if she says that she's 20 and then I am 22. But when I say longer, like 2 feet longer, I'm adding. When I say twice, I multiply. So you have to pay attention if you have to use the addition or subtraction. For example, if I give you the length and I say the opposite, for example, okay, the width is 3 feet shorter, then I have to get the length and subtract 3. Yes, so you have to be very good on that vocabulary from the chapter 2.1, where you have the tables, what those things mean. All right, so perimeter 42. The width I call W. And the length is what? 2 W's. And then the place of the length, I write 2W. How many W's do I have here? 2W. What is 2 times 2W? 4W. So this is 2W plus 4W equal 42. What is 2W plus 4W? 6W. Now what do I do to find W? Divide by 6. Then my W is what? 42 divided by 6? 7. So the width now is 7 feet. If the width is 7 feet, how much is the length? 14. The question is what? The width or the length? So now you have to come here. And this covering you cannot see. They want the what? The length. Pay attention what they ask. People go and jump and put 7 as the answer when they are asking the length of the room. So the length, so this will be this. So this is 7, 7, 14, and 14. If I want to test if I'm correct, I add all these green numbers and must be 42. Right? It's how you check your answer. Next, good. If this is 7, this is 2 times the width. Then I multiply 7 times 2 to find the width. The length, yes, thank you. 7 feet. 14, because it's twice as long as it is wide. Yes, got it? Pay attention how to read this. The keywords, twice, less than, more than. similar triangle, you can use proportion of correspondent sides. So they say that ABC is similar to DEF. And then they start to give you the numbers. Your side BC, this one is 6. When I finish, you guys are going to pay attention. Side EF, this one is 18. The picture doesn't make sense because this is the bigger one, not that one. When we created this, we put the numbers backwards, but you're going to get the spirit. The side DF is 12. So now I'm just marking my things. Then they want the side AC. Choose a variable to be AC. X, Y, Z, X, K, X. So this is the typical problem of proportion. I have 3 numbers and I want to find the 4th one. So I have to create the ratio which side is the same ratio, the same correspondent, BC and EF. So then I'm going to put BC here and EF here, right? Because they correspond, that they are the base. Both of them is the base of the triangle. Now the other one. What is the other ratio that I can create? X and 12. They correspond. And remember, I start with the bigger triangle on the numerator. Then I have to start with the bigger triangle on the numerator. Now what do I do here? How do I solve this? Cross multiply this and that. So 18x, 6, and 12. Now what do I do to make an x? Divide by 18. This is 1. Now I have the x. Now let's start simplifying things here. 6 and 6. What is this? 1 here, and here is 3. Now I have 12 over 3, right? Can I divide this? What is that? X equals 4. Yes, you can. The only thing that I say now, I try to avoid as much as I can to do calculation. And then I have to find ways to simplify that I do everything mental math as much as I can. But if you feel more comfortable to multiply these 2 and then divide by 18, you have to find 4 though. If you don't find the 4, you make a mistake somewhere, or on the multiplication or on the division. Okay, solve this application, another application. Word problems. What is this problem about? Who can tell me? Just looking at it. What is this about? Interest, right? Simple interest problem. So I need to know what? I need to know 4 things. The interest, principal, the rate, and the time. Awesome, you guys are on the ball. And what is the formula? I equal what? PRT. Okay, awesome. Okay. What did they ask you to find? The t, right? How many years? So the t is your point that you want. Then you must have what? The interest, the principal, and the rate. This Fred wants to borrow money. How much? $3,000. What is $3,000 then? The principal. Okay. How much he wants to borrow is your principal. His uncle decided to give him this $3,000 with a rate. How is the rate that I write? This is English. The rate will be what? How do I write? 0.028. So I get my percent, walk to the left. So I get my percent, erase this symbol, and start walking to the left twice. So this is the math expression of the percent in English. If you put a 2.8 here, you're doomed. You have to transform this into a decimal. And what is, okay, so then Fred does not want to pay more than $336 to his uncle. So what is this 336? This interest that he doesn't want to give to his uncle more than that. And then he wants to calculate how fast he has to pay this debt, so he cannot pay more than that. So let's plug in. So you have 336 equal 3,000, 0.28, and the t. Remember the trick that I told you? When you have a decimal and a number with a bunch of zeros, you walk one time to the right, cut one zero. Walk again to the right, cut another zero. Go again to the right and cut the other zero. Now you have 336 equal 3 times what? 28. Much easier, right, to do this. Everybody get this? This little manipulation. This is called arithmetic manipulation. How I'm an old lady, on my days, didn't have a calculator. We had to learn all the tricks that you could. And how you're on the same boat as me. Okay, now what is 3 times 28? Then let's do 28 times 3. 24, 6, 8, 84. 84t. And this is 3, 3, 6. What do I have to do to find t? Divide 84 on both sides, because now I make my coefficient 1 here, and then I have just t. And I divide this number. 336. What is that? I think that is 4. 4 times 4, 16. 32 and 1, 33. 0. 4 years. Fred has to pay his uncle in 4 years. So he doesn't pay more than that in interest. So any problem here that you see, that you envision, that you want to ask? No? And pay attention, the tricks that you can use. You can just cut as long as you have zeros. When you finish your 0, you stop there. Don't cut the 3, okay? All right. Yeah, don't cut the 3. Yeah, because I am making this number bigger 10 times. Then I make this one smaller 10 times. Then one compensates the other, right? But you stop as soon as you don't have more zeros to cut. You cannot cut numbers. It's just the zeros. Good? Okay. 21. So discounting is absurd. Né? I don't want to live on discounting. The sale tax is 9.5%, super high. And you buy something that's $419 and you want to know how much you're going to pay for tax only. They didn't ask what is the total price. They just want to know how much you're going to pay for the tax. So what you have to do then? Divide, multiply, add, subtract. I want to find what? What is 9.5% of 419? Multiply, right? Okay, good. All right. So let's translate this. How do you write 9.5% in math? 0.095. Okay, so when you so this is the way that we write this in a language, in English. I get rid of this symbol and I divide this by 100. When I divide, I walk to the left 2 times because my 100 has 2 zeros. Yeah, and then I put a 0 here, complete with a 0, and I have another 0 here to be able to put my dot here. Yeah, because percent, this symbol here means that you are dividing this number by 100. To the left. Okay, so this is your number correspond to this English here. What is the word of means? Multiplication. 4, 19. Can I do any of my tricks here? No, there is no zeros on this number. No tricks. So I have to go and do my brute force multiplication. Once 45, 4. Then you have 9 and you have 20. Nossa, this is not going to fit here at all. Let me erase. Tá. Let's do better. Now, this again. 4, 19 times 9500. Okay? 45 go 4. This is 9 and this is 20. I did the ones, now I'm going to do the 10. 9 times 9, 81, 8. 9 times 1, 9 and 8, 17, 1. 36 in 1, 37, 5, 0, 8, 9, 3. Am I done? I have to count my decimal places. And I have to add, how many decimal places I have here? Decimal places. None. This is a whole number, right? How many decimal places do I have here? 3. Then I'm going to count, add them together. 0 plus 3 is 3. I'm going to start to the right and count 3 places. 1, 2, 3. My point will be right here. Okay? Did you understand that? So, how much you going to pay for tax on this product that you bought? No, money, cash. The percent is already given to you. And this is the price of your product. And you apply this percent to this product. And they tell you to round, of course, on the near cent, because money is in cent. How many cents is that? $39.81. Because this gonna go away. And figure it out. We are talking about cash. Cash means that we have to find the cents. So this number must disappear. And when disappear, what do you have to do? Round it up, because this is a 5. And then this becomes 1. So see how much tax you pay. $39.81 is a lot, right? A lot. I don't want to be on this place. Okay, money has two points, 2 decimal places. So you spend like $2.14, $2.80. So you have to get rid of your third number. When you eliminate this number, you look what this number looks like. This number is a 5. Anytime that you have number 5 or bigger, you have to get rid of it, but you have to add 1 to the previous one. This is considered the rounding. Okay? Everybody clear? If it was not money, then here's dollar. Then it will be $40, right? Okay, got it? Okay. But they don't want the nearest dollar. They want to the nearest cent. Yeah, it'll be the next dollar. But it's not next dollar, it'll be the next cent. The next cent will be 81 cents. Exactly. Yeah, understand what they are looking for. They are looking for the money. Another one. Tyrone paid $165 for Tyrone. Paid $165 for an item that was originally priced at $570. What is the percent of the original price? So this then is what? Multiplication or division problem? This is a division problem. So what is the whole amount? 570. This is your this will be your denominator, the whole part. Okay? 570 is your whole part. And the partial you pay only 165. So you got a pretty good discount. They want to know what is this discount about. Okay, so then I have to do this crazy division. And I just say, I'm sorry, let's do it. I hope that we have nice problems. So denominator always outside of my long division symbol. And then the 165 is inside. Can I fit this number inside here? No. So put a 0 here. I multiply 0. I subtract and get 165. What do I do now? I put a 0 my leftover. But before that, what do I have to do? I decimal point on my quotient. Yes, I have to put a decimal point here and then add a 0 here. Don't forget that. How many times this number goes here? 2 times, not 3. 3, 21, 2, no. 2. Very good. 2 times, and then I have 4. So you have 4 here, 11, and here 0. Everybody agree? 2 times 7, 14, goes 1, 10, and 11. So let's subtract this. 0, 1, 5, 0. Now put a 0 here. Now seems to be a bigger number, right? How many times this number goes here? What about 8? 8 is too much? Because 8 times 5 is 40, and I have 51. I'm going to try the 8. Okay, so let me do here on this side. 570 times 8. 0, 56, 5, 45. Seems good, right? Should I try 9? No. 9 is 45, but then I have what? 9 is 45 plus 6, 51. It would pass. All right, let's put the 8 here. Now I have 4, 5, 6, 0. When I subtract this, borrow, I have to borrow. Then this becomes 10. This becomes 10, and then this would become, 10, 10, because it's 11. 10 minus 6 is 4. 10 minus 5, 5. And this is 0. Right? Because I gave 1 to this guy. Now, okay, let's put another 0 here. What number goes there? Do you think that 9 might? Okay, let's try. 570 times 9. 0, 63. 45 plus 6, 51. Yeah, go. 9 here. Now I'm going to do my subtraction here. 5400 minus 5130. 0, borrow, becomes 7. Here becomes a 3. 3 minus 1 is 2. And 270. How far do I go? I have to go farther because she wants the nearest thousands. So it's a lot. Because it's tenths, hundreds, and thousands. So let's put a 0 here. No, I already did? No. How many times this number goes here? Try 4. Okay, let's try 4. 5, 7 times 4. 0, 28, 22. Now 5 will pass, right? So it will be a 4 here. Then I go to 280 here. Borrow. Do 2. Here becomes a 6. Here becomes a 4. 420. Let's do one more. Yeah, but then for the percent. For the percent. What number should I try here? Cannot be 8, maybe 7. Yeah, it'll be a 7. I'm going to do right now. I'm going to just finish the 7, I'll do. Okay, now I have 570 times 7. 0, 49, 4, and 39. Perfect, right? So I leave this 7 there. Now I'm done. And what I'm going to do? This is a decimal. They want what? What is the percent? How do you transform a decimal into a percent? Walk back to the right? Because now I want to put that percent symbol. So I'm going to walk here to the right. And I would have what? 28, 9, 4, 7%. When I subtract this, I'm going to get a very small number here that would have a number here less than 5. I hope that you guys don't have to go to the thousands, because then you have to do like 6 numbers, because those 2 doesn't count as your thousands, because you have to transform 2% first and then count tens, hundreds, thousands. So this is a little too much. I know that the number that comes after this one will be a number less than 5. Yeah. Because this is the answer in math of the percent. The percent is given in math as a decimal. But your answer is asking, what is the percent? So you have to transform this decimal back to percent. And then you walk to the right 2 times and use the percent symbol. Stop where? Because they want your percent to be rounded to the nearest thousands. Then I have, this is the tenth, this is the hundreds, and this is the thousand. Okay? Has to be 3 places. It's a lot of division. I know. Yes. Yeah, when you transform back to percent, you walk right twice. When you have the percent and you want the decimal, you walk 2 to the left. Because percent is always is a portion compared to 100. Right? Okay, find the x-intercept for this equation. When you have the x-intercept, what do you have? y0, right? So I'm going to write this. X-intercept means that your y equals 0. If I put a 0 here, I have negative 3x equal what? 18. And then your x is negative 6. Then what is the x-intercept in order pair? If you put this there, I'm going to chop it off. Okay. How do you answer? You write negative 6, 0. This is the answer, not that one. Right? Because they want order pair. Yeah. Right? Next. This one. What they want? Y-intercept. Y-intercept means what? X is 0. So I start with my equation, put a 0 right here. What do I get? 5y equal what? Negative 140. Then my y is negative. You divide by 5 on both sides. And this number is negative 28. I think, yes, yes. 40 goes, 10, 14, yeah. 28, negative 28. Do I answer like that? No. How do I answer? 0, negative 28. Close parentheses. People do all kinds of stuff. They give me negative 28. They give me 0, negative 28 without the parentheses. And sometimes they write, those two options. So you have to put the parentheses. Parentheses is required. It's not optional. Okay, good? Move on. Slope. Let's find the slope and I give you 2 points. Who can tell me what do I use here then? Which one? Which one is on the numerator? Which one is on the numerator? Y on the numerator. Okay, y2 minus y1 x2 minus x1. Very good. Good job. Fresh. All right, so let's give the variables their names. So this will be my point 2, this will be my point 1, because I chose that way. If you decide to do backwards, no problem. Then it's my x of point 2, this is my y of point 2. This will be my x of point 1, and this will be my y of point 1. Now I just plot. Plot now, I just replace. There is no plotting here at this point. Y2 is what? Negative 7. Then I have a subtraction here of y1. Y1 is also a negative number. Divide by x2 is the number 2 minus, what is x1? A negative 13. What the numerator becomes? You'll be negative 7. Let's go 2 steps. 1, right? And this, what the denominator becomes? 2 plus 13. Very good. Thank you, Rochelle. Okay, numerator. Negative 6 over 15. Are you guys happy with this answer? Yeah. Okay, reduced fraction. Is this a reduced fraction? No. What is the common factor? 3. Then the answer really is negative 2 divided by 5. Now you're happy. This is completely reduced. This is the slope of the line that passed through these 2 points. Identify the slope of this line. So let's see if I can do this like that. Okay. Oh, very good. I want the slope. When I give a graph, what do I do? The rise over run. You guys have an awesome. You guys were paying attention in the class. I'm glad. Okay. So rise over run. Okay, gonna start at this point key, negative 8, because it's a whole number. This is 0, negative 8. And this is another whole number. They look very awesome. This is the y-intercept, this is the x-intercept. How do I get from the y-intercept to the x-intercept? How much do I rise? Pay attention where you are. On negative 8. How do you get to 0? 8. You go up 8. Okay, so 8 is positive. The rise is 8. Now I'm here on the origin. How much do I have to get to the x-intercept? 4. Okay, now this was a very tricky thing because you don't count the boxes. You see really the number. So you have to go up 8 units. This little box are count 2 by 2s. Did you realize that? Yeah. It's count 2 by 2. And then so it's 8 over 4. What is the answer? This is low. 2. This answer makes sense. Now the critical thinking. What is the inclination of the line? To the right, right? So it must be positive. So your answer makes sense. If you had found a negative slope, I made some mistake. And you had to review because the slope here is increasing to the right, going that way. 28, slope. 1 second, right? 1 second. Slope-intercept form, the coefficient of the variable x is your slope. Answer here is slope 9. 2 seconds. 29. Slope. What do I have to do? What form? Slope. Yeah, now pay attention here. What is this form of this line? Standard form. The only way for me to see is if I have the elegant form. How you call the elegant form? Slope-intercept form. How do I do slope-intercept form here? Solving for y. What's the first thing that you do? What do you do? First thing, to make y by itself, you have to do what? Yeah, take away 4x on both sides. Then here, 0, and I have 6y equal negative 4x plus 4. Now what do? Divide by 6 to make this coefficient 1. Now I have y equal negative 4 over 6 of x plus 4 over 6. What is this reduced? So what is that? Negative 4, 6 is the number. Negative what? 2 over 3. So then the slope, negative 2 over 3. Good? Okay, last one. Now, Okay, now I have this here. All right, look at this table. The table is XY, right? So this is the order pairs. What is order pair is this one? That one. Now, the middle one. What order pair is this? It's a special order pair. Is the, x-intercept, y-intercept? Which one is that? The y-intercept, because your x is 0. This is the y-intercept. So if I go and look the things that I have, which ones has the y-intercept -3? You have the C and the D, right? Now, B has intercept +3. And now, okay, pay attention. Y-intercept is the point on the y-axis. Which one has y-intercept -3? Because the x is 0. So you would eliminate immediately those two here. So can be this one or that one. Now I have to get another point to see if it belongs here or here. Let's get another point. Here. -1, -1 is an easy one, right? So let's see which of those two has -1, -1. C, then it's the answer. Okay, so you analyze your table, find x and y intercept to eliminate graphs that don't fit. And then you get another point and dispute between the two. Got it? You don't need to do one by one. So this is called strategy. You look at this. I immediately look to this. I look for zeros. And I see that this is a y-intercept. And then it's okay, which the line cut the -3? This doesn't. This one does not. But then those two do. Then I'm gonna between those two. Now I go back and choose another one. I choose this one because they're the same. Just for that. But you could choose anything. Okay? Good? Yeah. Answer C. Last one. We're gonna celebrate. Okay. This one is awesome. What is this form here of this line? It's the elegant form, right? The slope-intercept form. What is your slope? -5/2. And what is your y-intercept? -2. When you have a negative slope, how the line looks like? That way or that way? That way, right? Okay, so then we can eliminate. Which one we gonna take it out? B and D. Has to be this or that. What is the y-intercept? -2. Which of those two has the A? The answer is A. So those problems you do like 20 seconds. Okay? All right, so I am very proud of you guys to be here that long, and you guys are awesome.